Assalamualaikum warahmatullahi wabarakatuh and hi. My name is Shahrul Ikmal bin Abdul RAZAK. I am the student of CS 2413M2, Bachelor in Science Statistics from UiTM Negeri Sembilan, Cawangan, Seremban. My matrix number is 2019406052. Today, me and my partner AIMAN are going to explain about spherical cone based on this lab question by using Maple software. I will explain to you about this question and how to use the correct command. AIMAN will explain more information that can be obtained from the last solid from this question. Let's read the question. So the question asks, plot and present the solid that lies between z equal to the set of x squared plus y squared and the plane z equal to 4 by using any suitable computer algebra system. From the question, if we read the question carefully, what is your impression towards this equation? What will come out in your mind? Definitely, this equation z equal to the set of x squared plus y squared, it tells us that this is the shape of a cone. We need to know what is the coordinates for the spherical cones. So, the general coordinate for a spherical cone is this: rho, theta, and phi. This is the coordinate, the general coordinate for spherical cone. Back to the question. Okay, so this is the coordinate that I mentioned earlier. Why I use pi over 4 here? Why I replace pi over 4? Why I use pi over 4 instead of I use phi? Why I replaced? It is because pi over 4 is the fixed value of phi in spherical cone. So we can just simply replace phi with pi over 4. So this is the coordinate for this question. Okay, so for the range, rho I will put between 0 until 4 secant pi over 4. How do I get the value of 4 secant pi over 4? I obtain that value from this equation. Z equal to rho cos phi. So this is the general formula for Z for the spherical cone. Okay, so it is the fixed formula that we can use. So if we back to the question asks the solid that lies between z equal to the set of x squared plus y squared and plane z equal to 4. So we can just simply substitute the z equal to 4 value here equal to rho cos phi, and also the phi, like I mentioned earlier, the fixed value for phi is pi over 4. Okay, so we can just simply to substitute also here. And then, how do I get second here? The simple mathematical operation. Cos, if I put in the left hand side, it will become 1 over cos. So 1 over cos is equal to secant. So that's why the answer is rho equal to 4 secant pi over 4 here. So that's why I put 4 secant pi over 4 in a row here. And theta, let's say I will put negative pi to pi, and the chords is spherical. Definitely because cone is a spherical shape. Okay, and then from the first command, this is the solid that we obtain, a shape of cone, but with open upwards. Next, I will put this with plots. Why? It is because I want to join and combine the first command here for the z equal to the set of x squared plus y squared, and I want to join them, to combine them with the command plane z equal to 4. So this is the second command for plane z equal to 4. Plane equal to plot 3D like earlier. So this is still the coordinate, the general coordinate that I mentioned earlier, rho, theta, and phi. But here for the rho, I replace rho with I substitute the rho by 4 secant phi here. Why I use phi here? I do not use pi over 4. It is because this command is used to find the shape of the plane z equal to 4, not the cone. So that's why I put phi here. Instead, I use pi over 4. So theta and phi. The range theta is between still let's say I will put from negative pi to pi, and phi I will put between 0 until pi over 4. here you can put until pi over 4 here. And the chords also spherical. Okay, now so I want to join and combine those two shapes, okay, those two solids, the cone shape, the cone solid, and this plane Z equal to 4 into one absolute shape, one absolute solid. So by using this, display cones plane and scaling equal to constraint. Okay, so this is the final solid that we obtain in this question, a cone shape. But for the first graph, for the cone first cone, the upwards are openly. But now it is the close by the plane of Z equal to 4. Okay, alright. So this is the shape of this question. Now I will pass to my partner Aiman to explain more about what are the information that we can obtain from this cone solid. Okay, thank you.
Thank you. My name is NORSHAM HAZIQ and my matrix number is 2019252394. Alright, proceed to the presentation. When both of the equations combine, a cone shape diagram is formed. Basically, a cone is a solid that has a circular base and a single vertex. If the vertex is over the center of the base, it is called a right circular cone. If it is not, then it is called an oblique cone. These are some of the prepared images of oblique cones. Back to the question, the plotted diagram obtained is actually an inverted right cone with a circular base at the top of the diagram and a vertex at the bottom of the diagram. The radius of the circular base is 4 units of length, while the vertex is at point x equal to 0, y equals to 0, and z equals to 0. The distance between circular base to the vertex of the cone is the height of the cone with the length of 4 unit 2. We can find the volume of the cone by converting the triple integrals from rectangular to cylindrical coordinates. And here is the equation of the cylindrical coordinates. After that, integrate one by one, starting from z, then integrate r, and lastly integrate the theta. The final answer obtained is 64 pi over 3, which equals to 67.02 unit cubic. Pleasingly, if we calculate using the basic volume formula of cone, 1 over 3 times pi times radius squared times height, we still can get the exact final answer as stated before, 64 pi over 3. I think that's all from us. With that, thank you.